What if you could transform an evening gown into a short cocktail dress with the help of heating by a hairdryer, and then be able to stretch it back down again? Or what if a t-shirt was able to create ventilation holes when you sweat? Now you might think that these would only be possible with electronics, but thanks to hydrogels, these improvements in textile engineering are not far out of reach. Hydrogels are made up of polymers, and polymers are long chains of small organic molecules called monomers. You can think of a polymer like a paper chain, only made up of hundreds if not thousands of links. When a polymer cross-links, the chains connect to other chains, creating a polymer network. If this polymer network contains a hydrophilic polymer, meaning it absorbs a lot of water, it can be known as a hydrogel. Some common hydrogels you may be familiar with are contact lenses, Orbeez, or eye masks. So come on, I'll show you how we make hydrogels here in the lab. First, we dissolve the polymer into a water-miscible solvent and put it in a syringe. We attach that syringe to a pump, which pumps the solution into a RO water bath and creates a hydrogel fiber. The next step is taking the hydrogel and stretching it to about 5 times its original length. It dries out overnight and creates a fiber that is similar to a thin fishing line. These fibers are actuators, which means they shrink when heated or hydrated. This happens because each fiber consists of alternating regions of aligned chains called semicrystalline and randomly aligned chains called amorphous. Here are the fibers actuating in an oven where the numbers describe how much I stretched them from their original length. Next, I experimented with how much weight the fibers can lift to understand its energy density. The most it lifted was 2 grams and couldn't lift 3 grams. I thought these results were super cool, but I'm more interested in figuring out applications. So using my drop spindle, I spun together alpaca wool and the plastic fiber, and when hydrated, it created this super stretchy yarn. Then I sewed the fiber into a spiral on this cloth, and when heated, it scrunches up to create this cone shape. But that's not even the craziest part. You see, I discovered you can stretch the fiber back out and re-actuate it. This discovery led me to come up with the gown to cocktail dress idea. I made a small prototype, and although it wasn't perfect, it's definitely a start, and it created a cute high-low aesthetic. I also made a prototype for the self-ventilating shirt, and here were the results. So that's cool and all, but why does this matter? Well, we know fast fashion and overconsumption are big issues. By creating versatile fashion that has many uses, we can buy fewer clothes and work towards responsible consumption and production. So let me know, would you buy this?